Welcome to Junior Cycle Higher Level Maths. It's chapter 20, real life graphs. We'll be interpreting them and drawing them. And the section today is 20.2, directly proportional graphs on page 467. In this, we will be looking at graphs and interpreting what they're saying and see if they qualify to be called directly proportional graphs. So what do they mean? They are straight lines and they start at the origin 0, 0. So I'll begin by drawing. Now, to be directly proportional, and that's what this section is all about, directly proportional graphs. And we're starting there on the first page there and open page 467. Now, directly proportional graphs, they need to be straight lines, okay? So I draw a straight line. So to be proportional, it has to be a straight line, and to be directly proportional, it has to begin here at 0, 0, at the origin. And the definition they have there in the book is straight lines through the origin. So they have to be going here. Okay, so we all know this is the y-axis and this is the x-axis. So that's a straight line, and that's what we're talking about, directly proportional graphs. Now, when would that apply? The examples there would be maybe if you have converting euros to dollars, or if we were converting distance like miles to kilometers, or if we were looking at weight, you know, we had pounds weight and we're going to kilograms, or if we're looking at hours worked and pay per hour, those would be examples. Or we might have distance traveled and petrol used, or we could have distance traveled and the time it has taken us. So those are all examples where it would be directly proportional. Now I want to look at a real life example. This is a bottle of yop, and my pupils love to drink it. And I want to show you how we're going to represent this on the graph here about the cost and price of it and the different shapes we get, and to see if they are going to be directly proportional graphs. Now they sell yops in packets of 6, and we're going to look at the price of them there. They are usually €4. Okay, so if we measure that much up here, €4, and then we'll go up another little bit, okay, up to here. Okay, so we have 8, and this is going to be the euros, and this is 4, and then we're going to have maybe 2 there, 1, 3, this will be 6, 5, 7, and okay, that's it. And going along here then, we're going to have okay, 1 packet of yops there, and then another packet there. So 1 6-pack and 2 6-pack, and this is YOP. Okay, if we come up there to there, okay, that's that, and we'll just make sure the line is okay, that's fine. So what I'm going to do now is I'm going to run a straight line from the origin here right through this point here, and we'll see what that will do for us. Okay, little slippy on the surface there, but it's a straight line. So we see there, so for 1 packet of yops, we see is costing us €4. But once we have that put in, if we ask ourselves, well, if we're buying 2 packets, okay, what would it be? So we'll do a dotted line. I prefer to do a dotted line and going up. So here we are running up this line. Okay, and maybe, okay. So we know, and if you go to the shop, and I price for the shop, So one 6-pack of Yops is going to cost €4, and of course 2 packets are going to cost €8. So you can see when we have the graph drawn, they're exactly proportional. And if we moved out further and further and further, then we would see the same thing happening. So if we moved out as far as 3 packets, then we'd be going up as far as 12. So that's the big advantage of this. Once we have it set out for one, then it'll work for all of them. Now I want to show you a few examples where we wouldn't have a directly proportional graph. And I want to show you how that would happen. So we'll just take away this. This is the directly proportional one. And now we're going to look at a graph that's not directly proportional. Now, imagine you have to pay €2 to get the bus to the shopping centre to buy your packet of Yops. So, you're going to pay €2 and you're going to come up as far as here paying with the costs. But you still don't have any Yop. Then you go into the shop and you're going to buy the packet, and it's going to be, so up here you're going to have somewhere around there. So up there, roughly speaking, it's across there from €6, okay, and up there. So what you have done there is you've spent €2 on the bus, and then you had to buy your packet of Yops for €4. So then the whole thing is going to cost you €6. This is an example where it is not directly proportional, because the origin of this line here, this straight line, is not down here, it's up here instead. So that's one example where it is not directly proportional. Now, the next example I want to look at there is, you might go to the shop and we'll see what happens if he gives us a free Yop. So we're out as far as here, okay. So we're out as far as here with one free Yop, but it has cost us nothing. It has cost us €0. Okay, we're out here as far as one free Yop, and then we're going to, I just have to, up here as far as 2 and over as far as there, and roughly speaking, I suppose, there. So, and that's roughly across there from 2. So, that's an example there where we get one free Yop and then we have to pay for the second one. And again, it's proportional, but it's not directly proportional because it's not starting here at the origin, at 0, 0. Now, another example that might happen as well is we might, if I go out here and draw this for 1, okay, and whoop, there we go. And then we buy our Yop for €4, and then the shopkeeper says, well, you need a bag, so we have to pay €1 for the bag, so that'll be up around here. And it's going to cost us €5. So, and that's another example, okay, even though it's from the origin here, but it's not a straight line because we pay for the Yop first of all, and then we have to pay €1 for the plastic bag to bring it home for us. Okay, and then the final example I want to give is if we had up here, we had, if he gave us, for every one you buy, he might say, or for every customer that comes in, if you buy one, then you get one free. So up this way, and then it will bring you over here, and you get a second one free. Okay, you get a second one free. And again, that's an example there. Okay, it's costing you €4, and now we're going to get a second Yop over here. But it's not a straight line. So we need to get rid of this Yop now. Now moving on to question 8, and I just do one question in this section because, and this is the last question in the section, and I'll get you, the students, to cover all the others, but it's quite easy. This graph shows how much petrol 2 cars used. Okay, so we have Stephen up here is T-E-P-H-E-N, Stephen. And then we have David here as well, D-A-V-I-D. So, I suppose David, or what the, Stephen should be the one with the dotted line. Now, David's car travelled 80 kilometres. How much petrol did it use? So David's car travelled 80 kilometres. Now we need to put down here kilometres first of all, to be sure that we know what we're talking about. And up here we need to have litres. I'll put down L-T-R-S. Cut for space there, but anyway. Okay, so you travelled 80 kilometres, so here we are at 80. And we're going to move up here for David. So we're going to be around here about, and I'm going to look for a more accurate one here in the book. I suppose it's about there. Okay. So that's about 80. And go over here then, and that's about 8. Okay. So 80 and 8. So 80 kilometres, and then it is 8 litres. Okay, 80 kilometres and 8 litres. Now, Stephen's car used 9 litres of petrol one day. How far did it travel? So, we're going up here. So, we have 2 litres, 4, 6, 8, 9. So, we're going to use 9, and to Stephen's car, we're going to notice values. So, 9 is about there, and that brings us over to about here. So, that's 9 litres. And if we go up here, or come down from here, then that's going to be around 60. So we have 9 litres, 9L, and we have 60 kilometres. So 9 litres and 60 kilometres. And if we look at the book there, we'll see it more clearly. 9 over there and 60. Yeah, the book says the same. How much more petrol does Stephen's car use than David's car when each car travels 60 kilometres? So 60 kilometres. So we're going to have here, so we know for Stephen's car, he uses 9. So now we have to find out how much here David's car uses. And I think David, we can fairly say, uses 6. Okay, so put it down there for 6 kilometres. So if you look at it there, 6 across there. But if you look at, especially on in your book there, you'll see it more clearly, and 60k. So the question there was how much more petrol does Stephen's car use? So Stephen's car uses 9 and David's car uses 6. So the answer is 3 litres. Now the next question there, is this line graph directly proportional? And the answer is yes, it is. And if you go back to the first page there, and we've said it many times, first of all, it's a straight line, both of them are 2 straight lines, and they start here at the origin. And that answer is there on page 467. It makes it very clear. Directly proportional graphs are always straight lines through the origin. And that's the answer you need to give there. And the last part of this question, a little bit of work on that one, find the equation of the broken red line in the form y equals mx. So we're looking here for the broken red line. Now, the first thing you need to do there is you need to look for 2 coordinates along that. So maybe the best thing we can do there is look in our book while I clean the board. Now we're asked to get the slope of the broken red line that represents Stephen's journey. So the first thing we need to do is pick the 2 points. And these are the 2 points I've chosen, 20 and 3, and then you have 60 and 9. So I'm going to put down there x and y, and then again I'm going to start here with a 1 and a 2. You'll see why I'm using those as to represent them. The first thing we have to do to get an equation of a line is we need to get slope. So the formula for the slope is y2 minus y1 equals over x2 minus x1. And that's all with m before it. Okay, So when we look there and we're looking for y2, y2 is there at 9 minus 3. And then when we look at x2, we have 60 minus, there's x1 there is 20. So we continue down here and we have 9 minus 3 is giving us 6, and 60 minus 20 is giving us 40. And to make that a little bit smaller, 40 there, we're going to divide again by 2, and that's going to give us 3 over 20. So that's the slope of our line, m. So I put it up here, m equals 3 over 20. Now I'm going to clean the board off. Now when it comes to getting the equation, once we have the slope got, then there's putting in the y minus y1 equals to m, the slope, x minus x1. Okay, now since we're using the graph here, there's litres and there's kilometres, I like to use, they're more user-friendly when we come to later on in the question. So for x, which is the bottom line there of our graph, I want to put in k. So that's k for kilometres minus k1. Okay, and we still have the m for our slope. And then the y is going to be the line up, going up and down, the vertical line. And that's going to be, instead of y, that's going to be litres. L minus L1. Okay, so L is going to represent the litres and K the kilometres. Now, as we start to fill these in, so we have L minus L1, which is Y1, so Y1 there is 3, and equals M, so we have M up here at 3 over 20, 3 over 20, and then we have K, and then we have K1, which is X1, so X and 1, which is minus 20. Now, we don't like fractions inside an equations, so we get rid of this by multiplying everything by 20. So I'll just put that over here as a little piece of reference. That's what we're doing, we multiply everything by 20. So we have 20L multiplied by 3 20s is 60. Then, what happens now when we multiply this by 20? We're going to finish up with 3. And then everything inside in this stays as it is. K minus 20. Now we'll continue working that out. So 20L minus 60 equals 3K minus, we're going to bring all of them to one side. So we're going to have 20L, and then we're going to bring the 3 across, and we're going to give us minus 3K, and then we're going to bring this 60 over to here, and that's going to give us a 0. So we're going to finish up with, this is our equation, 20L minus 3K. Okay, and we know now the L is going to represent litres and the K is going to represent kilometres. So now as we move to the next part of our question there, now use this equation to find the number of litres used when the car travels 300 kilometres. So 300 kilometres. So what we have to do is slot in the 300 kilometres there. So 20L minus, okay, take out the K and put in the 300, and that's equal to 0. So we multiply that another little bit, 20L minus, and then 300 multiplied by 3, well, we can do that without the calculator, is 900, and that's equal to 0. So now, what are we left to do? We have to find out how many litres was used. So very simply, we're going to move the 900 to the other side of the equal sign. So 20L is going to be equal to 900. Okay, 20L. Now we can cancel out this 0 with this 0. And now we have 2L is equal to 90 and 1L is going to be equal to 45, and that's going to be litres, LTRS, or L will be sufficient in there. So that finishes our question there on question, is it 8? Yes, question 8. So, little challenging at the very end because we're going back to coordinate geometry. But the first thing is pick your 2 points. Then you have to get the slope. When we got the slope, you remember the formula for the slope, and over x2 minus x1. And there you see that's the formula for getting the slope of the line. This is the actual slope of the line there. And then once we have that, this is the equation of a line, and I transpose it into something more user-friendly. And once we've done that, it's very easy to just slot in our coordinate numbers up there and slot in our slope and work down through it. And then at the very last piece, we are told that Stephen travelled 300 kilometres, and how many litres did he use? And it's the most beautiful piece of work, really, geometry, to use coordinate geometry to find how much you used. But you could also have used it, you could also have found that out if you had the graph long enough. Now if he's travelling 900, I suppose the graph there only goes to 120 kilometres, so if it's just 300 kilometres, well, you need the graph a lot bigger. And that's the problem really with the graphs. They're useful when they're small numbers or within a small range of numbers. But when you start going beyond that small range of numbers, then you need something like coordinate geometry to get your answer. For the rest of the questions there, I'm saying they're quite easily done. Make sure you look at that question because that represents another question back there in question 5. Okay, so question 5 you're asked as well, use the equation. Okay, you're asked to come up with an equation there. You turn the line, find the equation of the line in terms of S and H. So yeah, you're asked to find the equation as well in question 5 there, the equation of the line. Questions 1, 2, 3, 4, they're quite easy questions really. Question 5, challenging. Question 6 is true and false. And question 7, which is the final one you have to do, that's quite easy as well, to just interpret what's there. So, wish you the best, and you should have no problem marching through these few questions. Thank you for joining me.